So the topic of section 7.4 is obviously fractals. And what is a fractal? We already answered that. A fractal is a pattern characterized by, what is that term? Self-similarity. Okay, as you zoom in further and further, you can see more and more of the same structure. As you zoom in, you see the same pattern repeatedly. Examples, and I showed you the PowerPoint, and so you can see some of these fractals in nature and also in works of art and music. All right, let's examine this. You've seen this before. Okay, you see that initiator? Maybe I will show you how to do this, because you'll have to do this and show me your work in your homework and other places. All right, so you have the initiator. And you see the generator, which, as we said before, is basically going to add, here's the end of the branch, the top end of the branch, 2 new branches will grow from this. Now you have 2 ends. And so this is step 0, step 1. Now let's do step 2. Okay. The question actually says the generator shows you what changes in each step. Try to verbally describe, we did that, right? So 2 new branches come from each of the ends on top. What pattern in each step? So step 2 would look like this. Go ahead and draw step 1. You have 2 ends, each of which is going to grow 2 more branches. Now, after the step 2, we have 4 ends right on the top. So step 3, go ahead and do step 2 first. Okay, each step you have to sort of copy the previous step. So now you have these 4 ends, right? And then you have 2 more branches coming up. Notice here the number of ends doubles each time. So step 2 ends with 4 branch ends, which is 2 square. Now you have 1, 2, 3, 4, 5, 6, 7, 8. And so step 3 will have 2 to the third, which is 8 ends on the top. And then, so in the next step, if you were to do the next step, you would be adding, maybe I use different color here. You would be adding, these 2 branches from each of these ends. You'll end up with 16 ends in here. Okay, so this is step 4. At the end of step 4, you'll have 16 branch ends. And that's going to look like this picture here, right? All right, so, and you can continue to do this. If you try to do this on computer generation, then you will have to write a special program, and that's what you're seeing in the book. All right, let's look at another example. This is example 2 in the book in section 7.4. And by the way, I encourage you to look into the look in the text of the section 7.4 in the textbook, because it gives you a lot more examples and more detailed explanations. If the initiator is a straight line segment and the generator is looking like this, okay, in the normal language, how would you describe this? A hint, sometimes it's called the speed bump fractal, because basically, you have this flat road, and the generator basically is to construct a little speed bump in the middle of it. But notice here, this is step 0. In step 1, you have 1, 2, 3, 4 line segments. So line segments. So guess what happens in step 2? Okay, I am going to briefly draw step 1. Step 1 looks like this. I'm making it a little bigger. Okay, notice here we have 1, 2, 3, 4 segments, right? And so in step 2, each of these 4 segments, listen carefully, each of these 4 segments is going to grow a speed bump. So instead of this little thing here, you're going to have that, okay? And instead of this straight line segment, you're going to have a speed bump in the middle of it. Same thing here, and same thing here. So this is step 2. Okay, you get that? Okay. Now step 3. How can I do this? All right. So maybe I can draw, and clearly I'm not drawing this very nicely, right? Because I could be using these fancy tools here, but that would take a long time and you have to be very precise about the angles and so on. So I am just showing you a sketch to describe what it looks like if you were to be able to draw this, nicely. All right. So after step 2, you basically have this. Right? Yeah, so this is what step 2 looks like. Now in step 3, oh, by the way, how many line segments do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So step 2 already has 16 line segments. Step 1 had 4 segments. Okay, you can see what happens here, right? Each time one line segment is replaced by 1, 2, 3, 4 line segments. So each time you multiply by 4, so you have 4 segments here, 16 segments, which is 4 square, and then in this one you're going to have 4/3, which is 64 line segments, even in the step 3. So step 4 is going to have 4 to the 4th power, which is 256 line segments. It's already really complicated. All right, so let me draw step 3. This line segment is going to grow its own speed bump. The same thing here, same thing here, same thing here. So every time you have this straight line segment, each of these will be growing a speed bump. Practice this. I mean, you have to do this on your own, not just watch me, in order to be able to draw this. Some of you may think it's annoying. Some of you may think it's fun. Like, wow, this is a lot of fun for math class. I get to draw pictures. All right. But it's good. I mean, this is, people don't think this is mathematical because it doesn't look like, numbers and calculations and graphs and functions. That's okay. Let me tell you a secret. Okay, mathematics is not all about numbers. This is actually a great piece of mathematics where you recognize and repeat a pattern. Okay, and so in step 3, you recognize we have now 64 line segments. Okay, and if you want to go continue to go on and on, eventually you will see, and you can see this online. You'll have what is considered a Koch curve, or Koch, it's a German word, Koch curve, okay? And that looks like a bunch of snowflakes. I will show you what it looks like. Okay, so the final, if you can define the final product, which basically means you have done enough iterations to see basically what that is supposed to look like. The result is what is called the Koch curve, and it looks like this. All right. And so again, it's a nice pattern, right? And you can see why some graphic artists are quite interested in these iterative patterns. And so that is that's an example of a fractal. It's a well-known fractal because it has a name. All right. So in the quiz for this section, you have a few things to practice here. All right, and I think you can go ahead and do this. Of course, if you don't know how to do it, you can look at the answer. And I think for this one, you will have to submit your own work through the Canvas portal for this online quiz. Okay, so go ahead and do that, and then make sure you do your homework. And that's it for chapter 7. Next time I see you, we will be talking about chapter 8, the final chapter that we are going to cover in Math 100. And appropriately, chapter 8 is about mathematics and politics. All right, have a wonderful day, and I will see you in chapter 8.